fractional replication of experiments. Now, what is fractional replication of experiments? Well, this is a technique that can obtain useful information using less replicates than a full experiment. This is used through the equation I raised to the m-1, where I represents the number of levels for each factor and m represents the number of factors. Now, what are some uses? Well, when dealing with a large amount of data, this allows an easier way to analyze the data. This is done by reducing the amount of treatments run for the analysis. And this also helps one accurately investigate large amounts of data. Now, let me pull out my laser pointer. What we can see here with this chart is that it shows the relation between the number of factors and the number of tests needed. As can be seen, when the number of factors increases, the amount of tests needed increases exponentially to amounts that are not feasible to work with. Therefore, fractional replication of experiments is useful in order to reduce the number of tests needed. And here we have a basic example of an experiment that one could use fractional replication of experiments for. What can be seen is that the leaf springs in this experiment have 5 factors, and each factor has 2 levels. What this means is through a basic run of experiments, the total number of tests needed to work with each factor and level is 32 total tests. Now, 32 tests is beyond the amount wanting to be run, so through fractional replication, raising 2 levels per factor to 5 to the minus 1 factors, we are able to produce a fractional replication of only needing 16 tests instead of the original 32. This option is useful for companies to save materials, money, and time. And here we can see a fractional replication experiment that is useful for civil engineers, in which experimenters try to estimate the rotational stiffness of timber joints. What we first see is the factors and levels are set, and the initial experiment would be 5 factors and 2 levels in which 32 tests are needed. This is not a viable option to have that many tests, so the experiment was reduced through fractional replication over here to 2 raised to the 4th, or 2 levels raised to 4 factors, and that came out to 16 total tests instead of the original amount of 32. And now there are some common problems with fractional replication of experiments. With fractional replication of experiments, not every factor can be taken into account, and that means that one of the factors used in the test has to be removed. And the results of fractional replication can be misinterpreted due to the removal of certain factors in each test.